For centuries, our comprehension of the Andromeda Galaxy relied entirely on Earth-based observations. However, thanks to significant advancements in technology and the launch of the James Webb Space Telescope, we now have a much broader understanding of this galaxy. We are currently at a pivotal moment, as the telescope has detected unsettling signals from Andromeda, sparking significant curiosity and concern within the scientific community. These unexpected signals have caught astronomers off guard and ignited intense discussions regarding their origin and the reasons behind the widespread attention they are garnering. Until recently, our perception of the universe was limited by the available technological tools. For hundreds of years, astronomers were convinced that the Milky Way was the entire universe. The discovery of the Andromeda Galaxy, however, revolutionized this perception. The roots of this discovery trace back to the 17th century, when Galileo Galilei was a trailblazer in demonstrating. We have shifted from relying on Earth-based observations to employing space telescopes like Hubble and the James Webb Space Telescope, each of which has provided deeper insights into Andromeda's composition and structure. These advancements have made Andromeda a key subject for studying galaxy formation and evolution. Understanding the relationship between Andromeda and the Milky Way is believed to be crucial for unlocking deeper cosmic mysteries. In fact, scientists predict that the two galaxies will collide in about 4 billion years, merging to form a new, larger elliptical galaxy. While this event is still far off, the James Webb Space Telescope's recent detection of a strange signal from Andromeda has intensified global scientific interest. The source of this signal remains unknown, but initial analyses suggest it could be linked to unusual activity around Andromeda's supermassive black hole. Some researchers speculate that it might be evidence of extreme gravitational interactions, while others wonder if it could hint at phenomena never observed before, possibly even signs of unknown cosmic structures or processes. As astronomers dive deeper into these signals, they've discovered gravitational anomalies in the surrounding star systems. This has reignited debates about the elusive nature of dark matter, believed to influence galaxy formation and structure. If these gravitational disturbances are indeed caused by dark matter, Andromeda could become central to solving one of the universe's greatest mysteries. Meanwhile, the increased activity at Andromeda's core seems to be affecting nearby star systems, accelerating their motion and disrupting stable orbital paths. This raises questions about the galaxy's internal dynamics and how these shifts could impact its eventual collision with the Milky Way. In response to these discoveries, global space agencies are collaborating on new missions dedicated to monitoring Andromeda. A proposed deep space probe, designed to orbit closer to the galaxy's outskirts, could offer humanity its most detailed observations yet. The mission would aim to capture high-resolution images, analyze stellar composition, and perhaps decode the origins of the strange signals. As research progresses, the scientific community is preparing for what could be a groundbreaking revelation, one that could redefine humanity's understanding of cosmic evolution and our place in the universe. As the investigation into the mysterious signals from Andromeda intensified, scientists around the world began to collaborate in unprecedented ways. The International Research Coalition, now called the Andromeda Signal Initiative, ASI, pooled resources from major space agencies, including NASA, ESA, and JAXA. Their mission was clear: to uncover the source of the enigmatic signal and understand its implications for the future of both galaxies. Preliminary data from the James Webb Space Telescope suggested that the signal was pulsing in a highly structured, rhythmic pattern, something not typically observed from natural cosmic phenomena. Some astrophysicists theorized it could be tied to exotic forms of matter or unknown interactions within Andromeda's supermassive black hole. However, a smaller but growing faction of scientists dared to suggest a more unsettling possibility: the signal might be artificial. To test this hypothesis, ASI approved the launch of Project Horizon, a deep space mission designed to send an autonomous probe, Aurora 1, toward Andromeda's outer edges. Equipped with advanced sensors and communication relays, Aurora 1 would take decades to approach the galaxy but was designed to send data back in real time using quantum communication technology. As the probe prepared for launch, Earth's most powerful observatories continued to monitor the signal. Then, without warning, the frequency of the pulses began to change. The rhythm accelerated, forming what some experts believed resembled a coded pattern, a sequence of prime numbers, often considered a universal sign of intelligence. The revelation sent shockwaves through the scientific community. If the signal was indeed artificial, who, or what, was sending it? And why was it aimed toward our galaxy? Amid this discovery, new data revealed another startling fact. gravitational fluctuations in Andromeda's core were intensifying. Stars were being pulled into chaotic orbits, and scientists feared that an unknown force, perhaps a secondary black hole or a newly forming galactic event horizon, could be triggering these violent disturbances. But the implications didn't stop there. Back on Earth, simulations suggested that the collision between the Milky Way and Andromeda could happen much sooner than previously believed, perhaps within 3.5 billion years instead of 4. Even more troubling was the possibility that the strange signals were somehow connected to this accelerated timeline. As Aurora, one launched into the vastness of space, humanity stood on the brink of a cosmic revelation. For the first time, it seemed possible that we were not alone, or that some ancient intelligence might have left traces embedded deep within Andromeda's heart. The countdown had begun, not just for the probe's arrival, but for the unraveling of one of the greatest cosmic mysteries humanity had ever faced. As Aurora, one propelled itself into the cold void of space, Earth was gripped by anticipation. Every nation, every scientific institution, and every curious mind was fixated on the same question: what will the probe find? Months passed, and the probe's advanced quantum communication array began transmitting early readings back to Earth. The first signals were nothing short of astonishing. Anomalies in the surrounding space near Andromeda's outer edges suggested the presence of immense gravitational distortions, far stronger than what Andromeda's mass alone could account for. Something, or someone, was exerting influence on the galaxy's structure. Then came the moment that would change humanity's understanding of the universe forever. As Aurora, one neared the edge of Andromeda's galactic halo, its sensors captured a transmission that seemed deliberate. Unlike previous signals, this one wasn't just rhythmic pulses or prime number sequences. It was complex, layered, and eerily structured. The signal revealed patterns resembling mathematical formulas, universal constants such as the Fibonacci sequence, pi, and the golden ratio, embedded within the transmission. Hidden in the background was what scientists could only describe as an audiovisual imprint, an intricate, three-dimensional pattern of light and sound that seemed almost like a message. Back on Earth, top linguists, mathematicians, and cryptographers raced to decode the transmission. Days turned into weeks, and then finally, a breakthrough. The message wasn't just a random collection of patterns. It was a star map, and at the center of that map was Earth. Panic and fascination swept through humanity. Why would an alien intelligence, or whatever was behind the signal, send a map highlighting our solar system? Was it a beacon of peaceful contact, or a warning? As the world debated the implications, Aurora, one continued its journey deeper into Andromeda's outskirts. Then, the probe's instruments detected something beyond comprehension, an immense artificial structure, larger than any celestial body ever observed, hidden within the galaxy's dense star clusters. The structure, dubbed the lattice, appeared to be a megastructure, possibly a Dyson sphere or something even more advanced, designed to harness energy from multiple stars simultaneously. Its geometry defied known physics, with impossible angles and shimmering material that seemed to bend space around it. As Aurora, one transmitted the first images of the lattice, something unexpected happened. The strange signal ceased. Silence fell over the monitoring stations on Earth. Then, moments later, a new signal arrived, clear, focused, and undeniable. It wasn't numbers this time. It was a voice. In a language that somehow transcended human understanding, the message was instantly interpreted by the AI systems monitoring the transmission. The translation was chilling in its simplicity. "We see you. Prepare." The world stood still. Was this a warning, an invitation, or something far more ominous? As governments mobilized, scientists scrambled to understand the true nature of the lattice and the civilization, or force, that had built it. And as humanity looked to the skies, one terrifying realization became clear. Whatever was waiting in Andromeda had been watching us for far longer than we had ever imagined.